Hi, everybody. Let's talk about section 4.4, parallel and perpendicular lines. So hopefully everybody recognizes what parallel means. Parallel means that those guys will never intersect. And here's how you look at them when you know the slope of lines. If two lines have the same slope, identical, both of the slopes are 1/2 or both of the slopes are -5/6, then they are parallel. The symbol for parallel lines looks like the double L in parallel. So I know that I've got that. Like if I name this line, this blue line up here, line X, and this line Y, I could say that X is parallel to Y. So same slope, parallel lines. Then we've got perpendicular lines. Hopefully you know what perpendicular looks like. Perpendicular lines, here's the important part, and we'll talk about what this means. If the slopes of two lines are negative reciprocals of each other, then they're perpendicular. Notice on the little diagram here, my perpendicular slopes. Perpendicular means it makes a nice, neat 90-degree angle in there. So I know that those guys come together by looking at their slopes. Perpendicular lines intersect and form a right angle, also known as 90 degrees. The symbol for perpendicular is, kind of looks perpendicular. It's an upside down capital P. So if this line is L and this line is M, I could say that L is perpendicular to M. Hopefully you got your cursive letters down. So now let's talk about that negative reciprocal thing. Here's what that means. That means that the two slopes, if you multiplied them, the product would be -1. Or some people prefer to look at it as they are opposite signs and, whoops, there we go, opposite signs and flipped fractions. So the reciprocal fraction with the opposite sign. So if one is positive, the other has to be negative. Notice on that diagram with lines L and M, the slope of line M, oh, that's L, I guess, is a -1/2. The slope of this line over here is 2. Well, they definitely have opposite signs. One's positive, one's negative. If I flip over or do the reciprocal of -1/2, that would be +2/1. So it's opposite signs and reciprocal. And here's the part that you got to take notice. If you need to find the slope of lines, the easiest way to find that is to put it into slope-intercept form, because we know that M always stands for slope. So if you've got an equation in standard form, it might be difficult to figure out the slope. So you actually have to do a little bit of work with that in order to identify the slopes. So I'm going to do some problems like the next one. So let's just do, well, let's start with 1A, I guess. That seems like a good place to start. Notice 1A, the equation, top equation, y equals 2x minus 5. The second equation, y equals 2x plus 12. Now it says, determine if the given equations are parallel, perpendicular, or neither, none of the above. So we know that parallel slopes are the same. We know that perpendicular slopes are negative reciprocals, and that's how I'm going to say it. So opposite signs and reciprocals. And if they're not either of those two, then they are not parallel or perpendicular. So for question number 1A, y equals 2x minus 5, what's the slope of this line? Well, if we're looking at y equals mx plus b, the number in front of the x is our slope, right? So 2. The slope of the second, y equals 2x plus 12, same thing. The number out in front of the x term is 2. Notice both of our slopes have the same value, so these guys must be parallel. So let's do 1b. I like 1a and 1b because these guys are already in y equals mx plus b form. Super easy to find the slope. So in the top equation, y equals 1/3 x plus 2. Seems to me my slope must be 1/3. Second equation, y equals negative 3x plus 1. Again, we can find that slope is negative 3. So can we eliminate that these lines are parallel? Totally not the same slope, so they're not parallel. Can we say that these lines are perpendicular? This is the order I always look. If they're perpendicular, they've got opposite signs and they're reciprocals. Well, what's the reciprocal of 1/3? 3/1, right? Both have opposite signs. So I'm going to say that these two lines are perpendicular. Opposite signs and reciprocals. So now let's do D. Notice the first equation. Is that in slope-intercept form? 3y is a big problem. We can't have a 3 in front of our y and have slope-intercept form. So if I've got 3y equals 2x plus 6, I'm going to have to divide everything by 3. This is that thing where I'm going to have to do some work. The 3's cross out, so now my equation is y equals, remember I can take that fraction 2/3 and slide the x off the edge of that fraction, and 6 divided by 3 is 2. So for this equation, first equation, now that we have found that slope-intercept form, now we can say that the slope equals 2/3. The second equation, y equals negative 2/3 x minus 1, thankfully, we don't have to do any work for that. There's my slope. It's a y equals form, so I know that my coefficient of my x is my slope. Are these guys parallel? Do they have exactly the same slope? You might want to say yes, but the question you should ask yourself is 2/3 and negative 2/3 the same point on a number line or a graph? They're not, right? One's on to the right of 0, one's to the left of 0. So these are not parallel. Are these guys perpendicular? They have opposite signs. Are they opposite signs and reciprocals of each other? Not. So that means these are neither. They're not parallel and they're not perpendicular. Therefore, they're nothing. They're just two random lines on a graph. That's all we got. All right. So these are kind of equations that we're going to talk about. Actually, let's skip this one. Let's go through this one. Write an equation of a line that passes through negative 3, negative 2, and is perpendicular to the graph of y equals negative 4th x plus 3. So I spelled it out for you here. The first thing we've got to do is find the slope of this equation right here. So what is the slope of this equation? Negative 1/4, right? Once I pull that negative 1/4 out of there, I put a big X through this equation. I don't need it. I'm not going to do anything else with it other than find the slope. So step 1, find. Step 2, ask yourself, is it parallel or perpendicular? What does B tell us, or what does the original problem say? Find the equation of a line that passes through that point and is perpendicular to that other line. So if I know that my slope is negative 1/4, what's a perpendicular slope? The opposite sign and reciprocal, I'm going to say positive 4. And then step 3 is to write the equation. Notice it says, and I'm always going to ask you about the form, just like back in section 4.2. Use the point-slope form to write the equation of a line. I'm going to want my answer to be in slope-intercept or y equals mx plus b form. So our m is now 4 because we found that by perpendicular. I know an x1 and a y1. So I'm going to do y minus y1. This should feel very much like a review back to section 4.1 and 4.2. So let me move these guys over. And let's plug our stuff in. So y minus a negative 2 becomes a plus, equals the slope m. X minus a negative 3 becomes a plus. I'm going to do the distributive property. So y plus 2 equals 4x plus 12. If I want this in slope-intercept y equals mx plus b, there's one thing left to do, which is to get the y by itself. So I'm going to minus the 2. So here's my final answer. Y equals 4x plus 10. Just did that little math problem, 12 minus 2. Right? So we're going to find the slope. We're going to decide is it parallel or perpendicular, and then we're going to write the equation. I guess I should add one more thing onto this, and that one more thing is check the form of the answer. Do you need to distribute? Do you need to put it in standard form? Do you need to put it in slope-intercept form? Do you need to leave it in point-slope form, which you would be finished with? So there's our steps. This is kind of actually important. I would highlight that or something. We're going to do a lot of writing equations, and that's really what we're going to do. All right. Let's talk about I think we're good. Let's talk about more in class if we need to. Our lesson summary. Here's what I would like to know. How can you determine if lines are parallel, perpendicular, or neither? And if I give you those two equations, number 1, what's the slope of equation 1? Number 2, what's the slope of equation 2? And number 3, are these lines parallel, perpendicular, or none of the above? So that's the end of section 4.4. We're going to write a lot of equations. Please go back and double check that. How do you know if they're parallel and how do you know if they're perpendicular? They're really important. We're going to use that a lot when we write equations like we just did. That's it. We'll see you next time.